Have you ever just stopped and wondered how your favorite app or website actually works? I mean, how does it handle millions of people all at once without just completely melting down? Well, I'll tell you, it is not magic. It's a blueprint. It's the secret architecture that powers our entire digital world, and today, we're going to pull back the curtain and build one from the ground up.
Okay, so let's just jump right in with a mind-blowing question. Think about a massive service like Twitter. We are talking about 300,000 requests hitting their servers every single second. How is that even possible? What kind of engineering wizardry stops the whole thing from just collapsing in on itself?
The answer, it turns out, is a discipline called system design. And honestly, the best way to wrap your head around it is to tell a story. So let's do that. We're going to imagine we've just launched a super simple app. And, well, it's about to get really, really popular. So first things first, what is system design? You can think of it as the master blueprint for a skyscraper, but for the digital world. It's the high-level plan that architects create before a single line of code gets written, all to make sure it can handle massive, massive growth without falling over.
It's all about making smart choices early to prevent a total disaster later. And here's a really important distinction. If your app is slow for just one person, that's a performance problem. But if your app is super fast for one person, but completely crashes when 1,000 people try to use it, that's a scalability problem. And system design is how we solve for scalability.
All right, let's get back to our story. Our little app. We launched it, and it's just sitting there running on a single, lonely server. But then, overnight, it happens. We go viral. This is amazing news, right? But it's also our first huge crisis. Suddenly, thousands and thousands of users are flooding in. Our one little server just can't keep up with all the traffic. It's slowing to a crawl, it's timing out, it's crashing. So what's the first thing you do? How do you stop the bleeding? Now you might think, let's just get a bigger, beefier server. That's called vertical scaling. And you can do that, but you hit a limit, and it gets crazy expensive fast. The much smarter move is what we call horizontal scaling. We just add more servers. But now, wait, you've got a new problem. How do you decide which user goes to which server? That is where a beautiful little thing called a load balancer comes in. It's like a traffic cop for your system, or maybe a bouncer at a really popular club, pointing every new person to the server with the shortest line. It spreads the work out perfectly.
Okay, phew, crisis averted. Our app servers are humming along, handling the traffic like champs. But our app is still slow. What gives? Well, we fixed one bottleneck, and in doing so, we just revealed the next one. The database. It just can't keep up with all the requests for data coming from our new army of servers.
So what's the solution? It's something called a cache. A cache is just a layer of super fast memory that sits right in front of our slower database. And the idea is brilliant in its simplicity. We just store the stuff people ask for the most right there in the cache. It's kind of like keeping your salt, pepper, and olive oil right on the kitchen counter instead of having to run to the pantry every single time you cook. And when I say the speed difference is big, I mean it is staggering. Just look at these numbers. Reading a megabyte of data from a pretty fast database takes about 1 million nanoseconds, but reading that same data from a cache in memory, a mere 250,000. That's a 4-time speed increase, which is an absolute game changer when you're getting hammered by millions of users. At this point, our system is starting to get more complex. We've got multiple servers, a load balancer, a cache. And as we add all these moving parts, we run headfirst into the fundamental rule of system design, a phrase you will hear engineers say constantly. Everything is a trade-off. There are no perfect solutions, only choices with different pros and cons. This brings us to probably the most important and maybe the trickiest concept in designing these huge distributed systems. When your data lives on a whole bunch of machines at the same time, you are forced to make some very hard choices. You simply cannot have everything. This whole idea is formalized in something called the CAP Theorem. Now, don't let the name intimidate you. All it says is that any distributed system can only guarantee 2 out of 3 things: consistency, availability, or partition tolerance. But here's the kicker. Network failures, or partitions, are just a fact of life. The internet is messy. You have to design for them. So the real gut-wrenching choice is always between consistency and availability. So let's just break this down real quick. Consistency means everyone, everywhere sees the exact same, most up-to-date data, period. Availability means the system always gives you an answer, even if it might be slightly out of date. And partition tolerance, like we said, just means the whole thing keeps chugging along even if some of its parts can't talk to each other for a bit. So which one do you pick? Well, it completely depends on what your service does. Think about a banking app. It has to choose consistency, right? You would much rather see an error message than see the wrong account balance. That's non-negotiable. But now think about a social media feed. It's going to choose availability every time. It's so much better to see a friend's post from a few seconds ago than to see a big, empty error page. Different apps, different trade-offs.
So, let's put all these pieces together. We've gone on this journey from one user to millions. We've scaled our servers, we've sped up our database, and we've made those tough but necessary choices about our system's guarantees. What does the final blueprint look like?
This is it. This is the blueprint for a modern, scalable application. You've got your army of app servers, managed by that traffic cop load balancer. You have that super fast in-memory cache acting as a speed boost. Your database is now replicated and distributed, making it reliable. And you've even got these things called asynchronous queues, which are like a to-do list for background tasks so the user never has to wait. It's the whole shebang.
And here is the truly amazing part. This isn't just some theoretical exercise. From your social media feeds, to your streaming services, to your online shopping, this fundamental blueprint, this invisible architecture, is humming away in the background right now, making it all possible.
So, if there is one single thing to take away from all of this, let it be this. Building for 1 billion users is not about finding some single magic bullet. It's the art of understanding the options, weighing the pros and cons, and making smart, calculated choices. In system design, there's no perfect answer, only the right compromise for the problem you're trying to solve.
And that brings us to the end. So now I'll just leave you with this question. The next time you refresh your feed, or you post a photo, or you buy something online, just take a second and think about the blueprint. What invisible systems, what clever trade-offs can you see at work now?